welcome to 3 series hardware training modules. Here is what's covered in this module. Faceplate, LEDs, keypad, rear wheel, wiring, magnetic module. We will start by looking at the faceplate of the relay. In the front panel, there are 4x20 characters LCD display screen allows visibility under varied lighting conditions. When the keypad and display are not being used, system information is displayed after a user-defined period of inactivity. Any trip, alarm, or pickup is displayed immediately, automatically overriding the default message. If the keypad is inactive for the preset screensaver time, the relay automatically shuts off the display screen. Below the display screen are the status indicators with 10 LEDs for the non-programmable type and 12 LEDs for the programmable type. These LEDs will show the status of the relay operation and status of the breaker, or for the motors or the transformers, depends on the application of the relay. LEDs can be in red, green, or orange color. The keypad allows user to navigate through the hierarchy relay menu, change the set points, and reset the trip alarm status without using a computer. In addition to the front panel operation, USB port is intended to connect to a PC loaded with Vista SR3 software. Setting file can be created offline and then downloaded into the relay with this port through the program. Next, we'll talk about more details of the LEDs. In these training modules, we'll only talk about LEDs of the 350 feeder relays. For 339 motor relays and 345 transformer relay, we are going to introduce their own LEDs on their specific module. In service LED will turn on to green when the relay is set to ready in the setup menu and no major self-test error has been detected. Trouble LED will turn on to orange when the relay is not programmed or upon detecting a major self-test error. Set point group 1 or 2 LEDs will turn on to green color to indicate the group of active protection elements. If set point group 1 is lit green, only the protection elements under group 1 will be active. The protection elements from group 2 will be inactive, vice versa. Trip LED will turn on to red color when the relay detects a fault and sends a trip command to the trip output relay. The LED will reset by reset push button or the software when the fault condition has cleared. Alarm LED will flash in orange color upon detecting an alarm condition, with element function selected as alarm. The LED will automatically turn off if the alarm condition clears. The LED will remain steady on if the function of the operated element is selected as latched alarm. Pickup LED will turn on to orange color upon pickup condition generated by any of the relay features. The indicator will turn off if no pickup condition is detected. Breaker open LED can be programmed to red or green color. When the breaker is open, the indicator will be on continuously. Breaker closed LED is also programmed to red or green color. When the breaker is closed, this indicator will be on continuously. Breaker status indication is based on the breaker's 52A and 52B contacts. With both contacts wired to the relay, closed breaker status is determined by closed 52A contact and opened 52B contact. Vice versa, the open breaker status is determined by opened 52A and the closed 52B contacts. If both 52A and B contacts are open or closed, the breaker is racked in the switchgear. Both breaker open and closed LED indicator will be off, and the relay will display breaker status fail, alarm message, and alarm LED will also flash in orange color. Front panel with programmable LEDs has 12 LEDs. The first LEDs are dedicated to in-service, trouble, trip, and alarm. Same color convention as non-programmable LED. The second column is for the source signal programmable LEDs. 1 to 4, LED 1 is red, 2, 3, 4 are in orange color. The third column is for LED 5 to 8. They are programmable in source signal and also in 3 colors, red, orange, and green. In the next section, we'll introduce the function of the keypad and also demonstrate navigation of the hierarchy menu structure with the keypad. There are 5 main menu headers in the hierarchy structure: actual values, commands, quick setup, set points, maintenance. With message for arrow keys, user can easily scroll through the page headers and subpages. The Enter key can be used to enter the subpage and to store the altered set points into the memory. The Escape key can be used to exit the subpage and to cancel a set point change. The Value key are used to scroll through possible choices of an enumerated set point. They also decrement and increment numerical set points. A Reset key resets any latched conditions that are not currently active. This includes resetting latched output relays, latched trip LEDs, breaker operating failure, and trip close coil failure. The auto reclose scheme can also be reset with the short counter being returned to 0 and the lockout condition being cleared. Now we're going to navigate through the front panel of the 350 relays. In this demo, we're using the HMI display of the Vista SR3 setup software. It will have the same display LED status and keypad as the real front panel of the relay. So we're going to show 3 headers among the 5 main headers of the menu. They are the actual values, the set points, and maintenance. So first we're going to press the menu key to see the main menus. We can see the actual values, command, quick setup, set points, and we can press the message arrow down key to see the next page is the maintenance. So going to the top by pressing the message arrow up key, we're going to see some values under the actual values. There's 2 ways we can enter the actual values, either by clicking the message right arrow key or press the enter key. So once I press the right arrow key, I can see I got A1 status, A2 metering, A3 records. I can press the message down arrow key to see furthermore. So I can see A4 is the target messages. So now I'm going back to the A1 status, and now I'm going to use the enter key to check what's under the A1 status. So I can see the clock, contact input, output relays, and logic elements, virtual inputs, remote inputs, remote outputs, and summarized contact inputs and contact outputs, logic element summarized. So now let's go into check the relay output
status. So going back to the output relay, and now we press the enter key. So you can see the first trip relay status is off. If I press the arrow key down, I can see the close is also off. And later we're going to simulate this relay output contacts to be on. We're going back to check the status. Now we can either press escape key to go out of this menu, or we can just press the menu key to go to the top of the menu. And second, I want to check another actual values is the metering values. So again, I can press the arrow key to enter the actual values, and using the arrow key down to press A2 metering and press enter. I can check the current, voltage, power, and I can using message arrow down key to check further the energy, current demand, and the power demand, thermal capacity. And we can even use this as a command to clear the energy and current demand and the power demand. So now we're going to go to the top to check the current values. We press enter key, and we'll see there's zero current at zero phase angle. Now I'm using my current test set to inject some current, so I can see some values displayed on the meter current. Okay, so I'm going to reduce the current back to 0. Another one is the actual values. We're going to check is the target message, but we're going to enable some protection element and try to simulate some operation of the protection element. The next part is the setup points. We're going to using message down arrow key to select set points and press enter. And in this set point, we see we have S1 relay setup, S2 system setup, S3 protection, and S4 controls, S5 inputs outputs, S6 monitoring. So we're going to do one change is the system setup. We can press enter key and press the enter key again. So now we can use the values key to change the CT primary current. So we can press the values key up and down to do the fine adjustment, or we can hold the key to just do the coarse adjustment. Okay, so if we want to save these new values, just press the enter key. We can see the set point stored. This is the flash message to indicate that this new setting being saved in the memory. Another type of the flash message we can see is under the command, is like a command executed. So another set point we want to do is the set protection element. We're going to go to S3 by using the message down key, press enter, and we're going to enter the set point group 1 and select the phase IOC1. And now we're going to enable the protection element by using the value key to set this to chip, and click enter to save it. So now if we using the current test set, we can make this phase IOC element to trip. Before we do that, we can check the pickup levels. It's 1 times CT. So we're going to, using the current test set, increase the current until the relay trips. So we heard the relay tripped, and we can see the front panel, the red LED trip lights turned on, and also the orange color for the pickup LED. And now we see the A4 target message for phase IOC 1 trip, and status is operate. It happened on the phase A. It's going to reduce the current. And now the element dropped, but the LED light is still on. So now we can press the reset button to reset the LED. And we see the reset OK. Okay, so the last one, we're going to go to the maintenance. We press the arrow key to the bottom. Then we press enter. And the first M1 is the relay information. It's very useful to let us know the actual relay's order code and firm number. So let's press the enter key and see the relay's name. It's called the feeder name. So you can give any name in your application. And then we can see this is the 350 feeder relays under the order code. And also we can see the main firmware revision is 2.20. And if you keep on pressing the message key, you can see lots of other informations about the firmware, the boot code, revision number, etc. So another good feature under the maintenance is that we can do the testing of the simulated LED and contact output. So if we press the arrow key down all the way to M7 testing and press enter, then we can see the false LED and false output relay. We're going to use false output relays to force the output relay trip to turn on, and then we check the status. So now we can press the arrow key down to the false relay, press enter, and first we see this function is disabled. We're using the value key to change this to enable, and click enter to save it. And next we're going to enable the relay 1 trip from off to on by using the value key, and then press enter. Now the relay 1 is turned on. We can see the front panel maintenance LED turned to orange color. If we go back to the actual values, press manual key and check the status of the output relay, going to A1 status, and check the output relay and press enter. We can see now the trip status is on. So that's how we can use this front panel to do the view of the actual values, status, metering values. We can use this to do the setup of the system setups, the protection element, and controls. And we can also use as a maintenance tools to check the relay information and do the simulated testing for the LEDs and for the output contacts.
Next, we'll give a detailed look at the rear side of the relay. First, we'll look at the draw-out type relay. In the draw-out type relay, the terminal A1, B1 are used for the AC-DC power supply. B2 is used for the ground. The rest terminals A2 to B12 are used for output relays. Column C1 to C11 are for the inputs. C12 is for the chassis ground. In the column D and E, 5 to 8 are used for the current inputs. 9 to 12 are used for the voltage inputs. For 345 transformer relay, they are all used for the current inputs. In the non-draw-out type relay, the terminal L and N are used for the AC and DC power supply. Ground port is also provided in the same connector. The whole column A1 to A21 are used for the output relays. Column B1 to B11 are for inputs. B12 is for chassis ground. In the column D and E, CT-VT inputs are the same as draw-out type relay. In the wiring section, we'll introduce how to wire the power, inputs-outputs, trip and closed circuit monitoring, CT-VT inputs, communication ports, and RFB. Power. The power supply to the draw-out type relay is wired to the terminal A1 and B1 and grounded on B2. For the non-draw-out, power supply is wired to the terminal L and M. According to the order code of the relay, there are two levels of the power supply, low and high. The range for the low power supply is 24 to 48 volts DC, and for the high range is 125 to 250 volts DC or 120 to 240 volts AC. Control power supply to the relay must match to the installed power supply range. 3-series relays has 10 digital inputs. C1 to C10 are for draw-out type and B1 to B10 are for the non-draw-out type. These contacts are wet contacts, and the inputs should be connected to the positive terminal of an external DC power supply. The negative side of the external source must be connected to the relay's DC negative rail at terminal C11 for DC draw-out type and B11 for non-draw-out type. The inputs can be programmed to different thresholds depends on the DC voltages. There are 4 threshold levels: 14 volts, 33 volts, 84 volts, and 166 volts DC. The maximum external source voltage for this arrangement is 300 volts DC. 350 feeder relay is equipped with 7 electromechanical output relays. 2 special relays from A type are designed for breaker, trip, and close, then for general purpose relay 3 to 6. And the last one is critical failure relays. Relays 3 to 7 are all from C-type relay. For draw-out type relay, terminals are from A to B12, and for non-draw type relays, the terminals are A1 to A21. Breaker monitoring, including trip and close coil monitoring, is performed by built-in voltage monitor on Form A output relays. Number 1 is for trip and number 2 is for close. The voltage monitor is connected across each of the 2 Form A contacts, and the relay effectively detects healthy current through the circuit. In order to do this, an external jumper must be connected between the terminals A2 and A3 for trip coil monitoring, and B4 and B5 for closed coil monitoring. As long as the current through the voltage monitor is above the threshold of the trickle current, circuit integrity for the trip or closed coil is effectively normal. If the trip or closed coil circuits get disconnected, or if in general a high resistance is detected in the circuitry, a trip or closed alarm will be set and the alarm maintenance LEDs will be on. 350 and 339 relays have 4 AC current inputs and 4 voltage inputs. 345 relay has 8 AC current inputs. The terminals are from E5 to D12. Same for the draw-out and non-draw-out. 3-phase inputs are designed as bus voltage, and the connection most commonly used are Y and open delta. The single-phase inputs is designed as the auxiliary VT voltage. Auxiliary VT input channel can be connected for the either phase to neutral voltage VAN, VBN, VCN, or for phase-to-phase voltage VAB, VBC, and VCA. For the Ethernet ports, there are RS-45 copper Ethernet or MTRJ fiber optical cable connection. The serial RS-485 two-wired communication port is provided on the terminal F3 and F4, which can daisy chain up to 32 3 series IEDs. ARIC B is a standard time code that allows time stamping of events to be synchronized among connected devices within 1 millisecond. The wiring for the ARIC B is on the terminal F1 and F2. Last, we'll take a look at the magnetic module inside the chassis or the captive unit. The draw-out unit can be drawn out while the captive screw is loosened and handle is rotated 90 degrees. Inside of chassis, we can see the magnetic modules sits at the bottom left side. It can prevent CT open circuit while relay is removed from chassis. On its top are the comms card and column F. On the right side are the columns A and B for the inputs and outputs. Now let's recap what we learned in the module. We introduced the layout of the face panel and then detailed introduction to the LEDs of 350 relays. We also talked the difference between the non-programmable and programmable LEDs. In the keypad portion, we explained the function of each button, then demonstrated how to use them to navigate the hierarchy manual structure of the relay by using HMI display in Anavista SR3 setup. On the rear side of the relay, we reviewed terminals that we already learned in the overview module. Then we gave the detailed information on each terminal's draw-out and non-draw-out type. Lastly, we pulled the relay and looked inside of the captive unit, magnetic module, and internal side of the terminals. And that concludes these training modules of the 3 series hardware.